So the next problem we want to try and solve is problem number 4 on the first relativity lab. Without trying to pronounce the locations of the place we're going, the problem is basically that we're starting in California, we're going to Nevada, they're separated by a distance equal to 1,000 kilometers, and we want to know how fast we can fly to go there. However, there's a tailwind that can help you. The way I want you to think about this problem is to sort of think about an analogy. Imagine that you have a river and you're on a boat. But let's make it a motorboat. And so on this motorboat, you are going that way. Let's suppose that you have a maximum speed you can go of 20 miles per hour. Well, if you can go 20 miles per hour, then you can go that fast. But let's suppose that the river itself is already moving 10 miles per hour. Well, then the velocity of the boat is going to be the velocity of the river plus the velocity of the boat relative to the river. And coming back, the same thing will be true, except for that the velocity will be in the opposite direction from the river. And so rather than adding, the speeds will subtract. The same thing is true for planes flying in the air. That planes have a speed that they can go relative to the background air. So if the whole air is moving, then the planes can go faster. And if the whole air is moving in the direction opposite from the motion of the plane will go more slowly relative to the ground. So that's essentially what's going on here. So there will be the trip over, where the plane will be moving at a velocity v relative to the air plus v wind. And then on the way back, the plane will be moving at a speed which is v minus v wind. That's because the wind will help it on the way out and will hurt it on the way back. So the time, we know that velocity times time is equal to distance. So time is equal to distance over velocity. So the time on the way over there is distance over velocity 1. Time on the way back is distance over velocity 2. So the time total, which is t1 plus t2, is equal to distance divided by velocity 1 plus distance divided by velocity 2. Velocity 1 being these two quantities here. So I can write this out then, where the total time we've been told is 2.5 hours. So we can write this out, and we can say that this is d over v plus v wind, and this is d divided by v minus v wind. So what do I do? Well, I can put this all over a common denominator, and what do I get? V minus v wind times v plus v wind times t total is equal to v minus v wind times d plus v wind times d. Over here then, if I then carry this up here, I have v squared minus v wind squared times t total is equal to 2 times the velocity times the distance. The velocity is what we want to know. The v wind we know is 300 kilometers per hour. The total time is 2.5 hours. The distance is 1,000 kilometers. So I can then rewrite this as a quadratic equation where I have v squared times t total minus 2v times the distance minus v wind squared t total equal to 0. And that's my quadratic equation, and I can then solve for v using the quadratic formula. Quadratic formula being minus b plus or minus the square root of b squared minus 4ac. In this, everything divided by 2a. In this case, a is t total, b is minus 2d, and c is c is minus v wind squared t total. So you plug that in, and what do you get? Well, we have 2d plus or minus the square root of 4d squared minus 4ac. AC is minus minus, so plus 4v wind squared t total squared. Everything divided by 2a, which is 2t total. So you can then just plug in 100 kilometers for d, 300 kilometers per hour for v wind, and 2.5 hours for t total, and you'll get two answers. One of which will be negative, one of which will be positive. The negative answer is a fake answer because it's basically telling you that one of your times is negative, which is not meaningful. So you'll have one answer, which is the positive answer, and that's the correct answer.